Okay, let's go back to the example handout that was on Blackboard. This is example 3. This is actually from the book also. This is from section 9.4. All right. A Pew poll using good sampling methods surveyed 1,064 teens. 787 of them said that they play racing video games such as NASCAR, Mario Kart, or Burnout. A sales manager of a video game company claims that more than 70% of teens are playing racing games. Does the poll provide convincing evidence that the claim is true? All right. So let's work this one out. We need our two hypotheses. The question is, does the poll provide convincing evidence the claim is true? So what's the claim? The claim is that more than 70. And this is a percentage. Now we're not talking about a mean. This is a proportion question. So this claim is that the proportion, right, not mu, proportion, is more than 70%, but written as a proportion, it looks like this. The opposite is that it's less than or equal to 0.7. Step 2. We find alpha. It says alpha is 0.01. So we're going to let 1% be unlikely. This is a proportion. Proportions are always z. So this is a z distribution. This is going to be a z-score. And I need to decide if it's right-tailed, left-tailed, or a two-tailed test. So I think about my alligator. Right, this is a right-tailed test. So I need this area to be 0.01. This space over here is 0.99, and I need a critical value. And because this is a z-score, I can look this up on the table. Actually, let me show you where that is in case I wanted to do that. I can look up 0.01 and go all the way to the bottom where it says z and look that up. It says 2.326. But we can also do this one on the calculator. And I just have my Casio. But if we do distribution, normal, inverse normal, right? I put area to the left is 0.99. Standard deviation 1, mean is 0. And I get 2.326. Yeah, that matches what the table said. Okay, so we can use the table or we can use our inverse normal function on the calculator. Let's look at step 3. Now, this step for proportions is more complicated. I need a good random sample. I need 2 outcomes only. I need a population 20 times bigger than my sample. And I need at least 10 in each group or category. Okay, so it says this was a Pew poll using good sampling methods, so this is a good random sample. Check. Only 2 outcomes. Well, they asked, do you play video racing games? Yes or no? So that works. Population 20 times bigger than n. So this is my n, right? N is 1,064 teens. That's a big sample. But what's my population? My population is teenagers in the United States. If I multiply this by 20, that's it's still nowhere close to the population of teenagers in the United States, because there's got to be millions of teenagers in the United States. So this works. Population's really big. At least 10 in each category means I have to have at least 10 people who don't play racing games and at least 10 people that do play racing games. I've got 787 that play racing games. So I've got close to 300 people that don't. So that works. So everything works. This is a good random sample. All the requirements are met. Let's put it in the calculator. So to put this in the calculator, we're going to go to Stat and Tests, and we're looking for one prop Z test. And it's going to ask us for the proportion in the null hypothesis. It's going to ask for X and N, and it's going to ask for the alternative hypothesis. All right, so P sub 0 is the value in the null hypothesis. That's 0.7. X is the number of successes, or the number of people that agreed with whatever it was we're trying to count. So X is 787. N is 1064. And my null hypothesis is going to be greater than P sub 0, right, which is that 0.7. But I'm going to do it on my Casio because that's what I brought home. So test Z, 1 prop Z. All right, so I pick greater than. P sub 0 is 0.7. X is 787. N is 1064. And there's my results. So I got Z equal to 2.82. P is equal to 2.38 times 10 to the negative third. Right, do you see that? This is, P has to be a probability. It can't be bigger than 1. So this is not a really big number. It's actually a really small number because we have to move the decimal point 3 places to the left. P hat is X divided by N. So it calculated that for us. That is not the same thing as the P value. Right? This is a probability. This is my sample proportion. Okay, so now that we've got our test statistic and our p-value, we can make a decision. Step 5. In a right-tailed test, right, because this test statistic of 2.82 is greater than my critical value, which is 2.326, we are going to reject the null hypothesis. And to go back to this picture, right, here's my mean. If I go out 2.82 standard deviations, I'm out here in this rejection region. Right, so I'm going to reject the null hypothesis. Also, P is 0.00238, which is less than alpha. So again, P is low. I can reject the HO. If I reject the null hypothesis, this is my conclusion. So that video game manager said more than 70% of teens are playing racing games, and we can conclude that, right? We can conclude more than 70% of teens are playing racing games. Step 7. Did we have any doubts about this poll? Anything that made us think maybe this isn't really doing a good job? No, everything was okay, right? Good random sample, really big sample, really big population, everything's fine.